So now let's look at some pieces of this, as we aren't going to jump in and just start graphing. We're just going to look at pieces of it till we get used to it. So we're at the bottom of page 1 of 10.5, and starting at number 2 here, the instructions say, very important to read the instructions, really helps you here. Determine if the parabola, the given equation, opens up or down. And that means that we're looking at the a value. Okay, so again, your a is that coefficient in front of the x squared piece. Ax squared plus bx plus c equals y here. Y represents all the possible points on the parabola. We've been used to seeing 0 here, but now we know that that's getting us our x-intercept. So y represents all the possible y values on the parabola and all the pairs of x, y that then work to make this true. So let's look at our a value here, and if it's positive, we know that the parabola is going to open upwards. If it's negative, it's going to open downwards. So in this first one, our a value is 1, we've got ax squared plus bx plus c. All we care about is a equals 1. That's positive, so that means this parabola opens up. So the basic shape we know is going to look like this. The vertex is on the bottom and the graph continues up. And parabolas go forever, so be aware of that. That's why you draw these little arrow tips on the end. Okay. Now let's look at number 4. Take a moment. What's different about this one before you just jump right in? Sure, it's negative, but it also has a 2 in front. But that doesn't change anything. All we're looking at now is that a value in front of the x squared piece. So we've got y equals, that's good. We're set up in the equation form, y equals ax squared plus bx plus c. So our a value here is negative 2. So it is negative. That means it opens down. So the picture is going to have its little vertex and then it's going to open. That's the basic idea. And again, the little arrow tips to show that it does continue on forever. It just gets wider and wider and wider as it goes. Okay, so you'll do a few like that. Then the next step is we're going to practice x-intercepts. Find the x-intercepts for the parabola, the given equation. If the x-intercepts are irrational, round to the nearest tenth. So you're going to get some nice numbers, you're going to get some radical numbers, you're going to go ahead and get as close as you can by rounding to the tenth. That way you could potentially graph them. If you just stop at radical 15, it's like, well, what is that number? Where do you put that on a graph? But, 3.7 is easier to kind of locate, approximate on the graph. So let's look at number 6. Y equals x squared minus 6x plus 5. So the x-intercepts is what we've done so far. We let y equal 0. This is what we should be used to now. We've been practicing it since chapter 7, how to solve a quadratic. And we have lots of things at our disposal. We can factor, we can use square root property, we can complete the square, we can use quadratic formula. Now you guys have to decide what your best strategy is. Now for me, I've done this long enough that I take a moment to kind of see what would be my most efficient. So in this case, I am looking at can this factor? I've got a value of 1 here. It's very possible that I might be able to find a factor, and 5 only has a couple possibilities, 1 and 5. So if I can get a combination of 1 and 5 to add up together to give me a negative 6, I can do that with a negative 1 and negative 5. So x minus 1, x minus 5 is equal to 0. It does factor. Again, we're trying to solve for x here. So we let y equal 0, and then we solve for x, whether you're going to factor, whether you're going to use square root property, and the factoring comes from 7.6, the square root property came from 10.1, or you might choose to go quadratic formula, which is a version of completing the square, and that came from 10.3, just the previous section. So when you solve for x here, now I've chosen to factor, and then I can use the zero product property. So either x minus 1 equals 0 or x minus 5 equals 0, because I've got two things being multiplied together it equals 0. One or the other has to equal 0. So solving from there, I add 1 to both sides, I get x equals 1. Add 5 to both sides, I get x equals 5. Now, don't be alarmed. Two solutions make sense, because remember, these are x-intercepts. This is where it crosses the x-axis. So if we were to start imagining where this, what this graph looks like, it's going to cross at 1, 0. Remember, we let y equal 0 right here. So we've got the point 1, 0, 1 for x, 0 for y, but it also creates a 0 at y when you put 5 in for x. So 2, 3, 4, 5. So here's one of the x-intercepts at 1, 0. Here's another x-intercept at 5, 0. Now that's all we know. We haven't investigated anything else on this particular round. We've just looked at the x-intercepts. But if you'll notice, this same equation was what we looked at on number 2 when we looked at does it open up or down. So now we know that this opens up and it crosses at the x-axis, or crosses the x-axis at 1 and 5. So we're getting a little bit more information here, and we'll get a clearer picture as we keep going through. Let's try number 10. Okay, what's different about this one? Well, this is the same formula we had in number 4, which now is -2, which means it opens down. That -2 might make it a little bit more difficult to factor here. I may choose to use a different method on this one. So let's look at it a little bit. Same idea though. Let me draw the curtain here, get some privacy on this problem. We're going to let y equal 0. So 0 equals -2x squared minus 4x plus 6. Why do we let y equal 0? Because we're trying to find the x-intercepts. And wherever a graph crosses the x-axis, the y-coordinate must be 0. So we put 0 in place of y. I could factor out that -2 and make the numbers smaller. In fact, I might do that. I'm kind of thinking ahead here. This is something you can do. You don't have to. You could go right to quadratic formula with a value of -2, b value of -4, c value of 6, and solve for your coordinates here. But I'm thinking, well, I'm trying to decide what would be the best thing. I know I could go pretty quick with factoring, but I'm wondering if I should show you a different way on the notes. I think I'll go ahead and use quadratic formula. Let's say I didn't remember that I could pull the -2. Let's say the negatives maybe make me nervous, or I'm just one of those people, I just want to use the quadratic formula anytime I can. Okay. Alright, I can deal with that. So I've got a equals -2, b equals -4, c equals 6. When can we use the quadratic formula? Anytime you've got a quadratic, an x-squared equation set equal to 0, and you can identify your a, b, and c values. So then our x-coordinates of our x-intercepts are going to be equal to -b plus or minus big old square root b squared minus 4ac, the whole thing over 2a. So what does that look like when I give myself room to put everything in? Oh, way too crowded. Let's try over here. -b plus or minus big old square root b squared minus 4 times a times c, the whole thing over 2 times a. Now I'm free to plug it in here. Let's take that b value of -4. Notice it's -b, so it's the negative of the -4. Parentheses really help you not to lose those negatives. And then I square that b value. Again, I'm just plopping the values in here. A value is -2, it's also on the bottom. C value is +6. Okay, negative of -4 is a +4. Plus or minus, -4 squared is 16. -4 times -2 times 6 is +8 times 6, that's 48. Whole thing over 2 times -2 is -4. That becomes 4. That becomes, I'm sorry, got a little distracted there from my notes. 4 plus or minus 16 plus 48 is 50, 64. Whole thing over -4. Ooh, this one turns out to be nice numbers, which as soon as you get a perfect square right here, I could have factored this fairly easily. So 4 plus or minus, radical 64 is 8, so 4 plus or minus 8 divided by negative 4. So my two answers are 4 plus 8, which is 12 over negative 4, which is negative 3. My other one is 4 minus 8, which is negative 4 over negative 4, which is positive 1. So my two x-intercepts in this case are going to be negative 4, 0, and 1, 0. So from up here, we know that it opens downward, and it's going to cross the x-axis at negative 4, 0, and 1, 0. All right, here's one for you to try on your own, finding the x-intercepts. You could also practice doing the up and down here. So make sure your notes are clear for yourself. Talk it through either just to yourself or with somebody. That's one of the best ways to get into long-term memory. And then pause the video and try number 8 here on your own. Okay, so if you went ahead and tried the up or down, you should have gotten that this was a down because your a value is that negative 1, that negative in front of. And then in terms of your x-intercepts, there's two of them. Negative 3, this crosses the x-axis at negative 3, 0, and also the point 1, 0. And again, I'm happy to do that together in class. And let's we'll move on to the next page and do a little bit more practice with graphing quadratics. Oh, looks like I went off. Oh, sorry, I forget to adjust there. So I'm going to let the camera kind of hold this for a second. I talked right off the screen, working my way through simplifying earlier to get the negative 4 and the 1. So hopefully you'll be able to catch that, and maybe I'll see if I can zoom in and still get a clear picture of that. Not bad. And then there's your x-intercepts for the try one. Okay, sorry, I'll try to be a little bit more aware of that in the future. Okay, we'll see you on page 2.